This algebraic fraction has a linear expression on the numerator and a quadratic expression on the denominator, and would you know how to sketch it? So with any of these sketching questions, the first thing is to find the axis intercepts, and we can find them by setting x equal to 0 to find the y-axis intercept and y equals 0 to find the x-axis intercept. So when x equals 0, we just get minus 3 divided by minus 3, which is just 1. So we find that 0, 1 is our y-axis intercept, and when y equals 0, or when f of x equals 0, when we multiply by the denominator, we get 0 multiplied by the denominator. So we just get 0 is equal to x minus 3, so x equals 3. And that's our only x-axis intercept. Now we need to consider what happens when the denominator is equal to 0. Obviously, we cannot divide by 0 because that is undefined. So what values of x make this denominator 0? So that's when 2x squared plus x minus 3 equals 0. And we can actually just factorize this. So we're multiplying to negative 6, adding to 1, so 2x squared minus 2x plus 3x minus 3 will factor into 2x times x minus 1 plus 3 times x minus 1, or 2x plus 3 times x minus 1 equals 0. So either x equals 1 or x equals minus 3 over 2. And these are our two vertical asymptotes. So we indicate them with a dotted line. So that's x equals negative 3 over 2. And I'll just get rid of this working to add our vertical asymptote when x equals 1. Now, finally, we need to figure out our horizontal asymptote. And the horizontal asymptote for expressions for algebraic fractions like this is always the same, because as we consider when x goes towards infinity, the denominator, because of this squared, is going to grow much faster than the numerator. So that means over time, our overall fraction is getting closer and closer to 0. So I'll just add a kind of dotted line over the top of the x-axis. But now we just need to figure out the shape. So we need to figure out what happens close to the asymptotes. Is the fraction positive or negative? And then we know which direction the function is going in. So we need something slightly less than minus 3 over 2 to check to see whether it's going to be positive or negative. So minus 2 minus 3 will give our numerator, make our numerator negative. And then if it's 2 times minus 2 squared, minus 2 minus 3, well, that's going to give us 8 minus 5, which would be minus 3. So our numerator is negative, but our denominator is positive, okay? So that means it's going to be coming up. The overall fraction is going to be negative, and very close to the asymptote, we're going to be coming up in this direction. And we know it doesn't cross the x-axis on this side of the graph, so it's just going to get closer and closer to this asymptote. In between these two values, well, here, the numerator is going to still be negative, but also the denominator is going to be negative. So the overall fraction is going to be positive, and it's going to come down from the positive infinity direction and look something like this. And again, we know that it doesn't cross the x-axis here. For this last part, we're looking at values that are then slightly greater than x equals 1. So for example, we could sub in x equals 2 and see exactly what is going on. So when x equals 2, we get 2 minus 3, the numerator is negative. Well, that's going to be positive because it's going to be 2 times 2 squared to 8, plus 2 is 10, minus 3 is 7. So the denominator is going to positive, but the numerator is negative up until we reach this point here. So it's going to come up in this direction, cross the x-axis, but then because we've got this horizontal asymptote, it's going to get closer and closer to that over time. So this is the final sketch of our graph. If you liked that, let me know in the comments and drop me a follow.